Hi, the target of this exercise is to make practice with the key function editor. In fact, in our application, we used several times the key function editor, but with a very simple code, with just one line and just one parameter. So in this exercise, we will write here something more complex. We will also see a new feature of the simulator that are the breakpoints. So as usual, I will implement a typical real need and requirement of an application, that is the UnitStatus. So we will start creating a new variable called UnitStatus, a Boolean variable in the permanent memory, representing the status of the unit. So when the variable is 0, this means that the unit is off, and so all the devices will be forced off. More or less like in the previous exercise, we have enabled the cooling and heating devices with the enable cooling, enable heating. While when the variable is 1, the unit is on, and so the devices can start according to the other condition. So here below there is the code that, a pseudocode in a pseudo language, what we have to write in the key function editor. Well, now the point is how to change the unit status. In this exercise, I will use a new key combination, ask and up together. In our previous exercise, we have created the key combination enter PRG to enter in the configuration mask. Now we will create a new key combination for this purpose. So every time we press the ask up keys, we will execute this code. So if unit status is 0, it is set to 1, and vice versa. So every time we press the keys, the variable changes from 0 to 1, 1 to 0, 0 to 1, and so on. Okay, the code looks quite simple, but you will see that there are a couple of issues, and one of the target of the exercise is to face them. So first step, we have to create the variable. So I will create the variable here in the variable list. Right click, add unit status, description. Okay, the variable, the memory type, as told you before, I prefer to place it in the permanent. So in case of blackout, the status of the unit will be the one before the blackout. But in some application, could be better to use RAM in order to leave the unit off, and in order to force the user to switch it on again. Anyway, this is an exercise, permanent is correct. Data type Boolean, because we need only 2 states. Default is up to you, but I will use 1. Format only 1 figures, that's good. Field access doesn't matter because we want, no, we will use output, so we can show the variable in the mask, but in read only, so only output. Okay, it's all. Finish. After that, we have to create the key combination, ask up. So if you remember, you can create a key combination here in the key list of the terminal editor. So right click, add key combination. So ask up. The name, the default name is the name of the 2 keys. You can change if you want, but I prefer to leave this one. Now we have to write the code. If you remember, in the previous exercise, I show you the 3 levels of code: global, mask, and field. So I remind you that before to write a code here in the key function editor or set a property, we have to click and select the right level. Global, mask, or field. Okay. So since we want, I suppose also you want to change the unit status regardless the mask and the field where is the cursor, we have to select the global level. After selected the level, we have to select the name of the key. So is ask up, here is, and then start to write. Okay, I make more space. So if you remember, the magic key is control space. The statement is if to evaluate a condition, between parentheses the condition or conditions. So if control space US for user var list collector. If as soon as I press dot, here is the list of all the user variables. Now I type U to select the variable starting with U, enter. The operator is equal 0, close. Okay, please note that here I wrote equal equal. In fact, equal equal is the operator for comparison. Equal, not greater than or equal, less than or equal, not equal. Less than or greater than are not available. Because I told you that there is a very restricted implementation of the C language. So, if this condition is true, what happens? The system will execute all the following statements between open and close curly brackets. So, the statement is we have to set the control space the user variable unit status to the value 1 semicolon and close curly parentheses. So we can read the code in this way. If this condition is true, then the system executes all the following lines between open close parentheses. Please note once again that equal equal is the operator for comparison, while a single equal character is for assignment, to assign a value to a variable. And then the opposite. Control space if space open parentheses control space user enter dot unit status dot not dot is equal 1 or not equal 0, okay, the same. Open parentheses control space user var list enter dot unit status enter equal 0 close semicolon. Well, that's all for the code. Just one remark, what I will remind you later, is that I wrote this code in 8 lines, but you can use you could write all the code in one single line. In fact, the space, the tabulation, like here, and the space also here, the carriage return are optional characters. So I use them just to increase the readability of the code. Well, the exercise is not finished, but we have the variable, so we can have a quick test in simulations to see if it works. There is an error, not regarding this exercise, but the previous, so let's have a look. Probably I wrote some garbage. In the meantime, it compiles. You saw that if the compiler reports errors, if you double-click the message, the red line, usually the system is able to bring you on the error, in the line with the error. Okay, start. Now I add the variable unit status. Here is. By the way, you can see that there is something that looks strange. There is a Boolean variable which has a value out from the range 01, that is 201. So probably you can guess what is this value. This value probably is the set point, the value of the set point in previous exercises. And so we will spend more time regarding this issue, but for now I can tell you that as a general rule, every time you add new variables in an application, new variable in the permanent memory, you should install the default values, as there is the risk that you have variables with a wrong value. So I remind you how to install the default values. You have to stop the simulation, click this button, load DV file. The DV file is the file containing the default values. Start, and now it's better. In fact, you can see that the unit status is 1. That is the default value I defined in the unit in the variable list. So, what do we expect? We expect that every time we press ESC up, unit status changes value. Okay, let's try ESC up. So now unit status is 1, click, becomes 0. So, works. So I change again to 1, click, becomes 0. So it seems that works. But if you click again, you see that there is a problem. You see that the unit status is 0 and remains 0. It doesn't change to 1. So why this happened? So what's wrong with this code? Okay, to find where is the code, we can use a new feature of the simulator, that are the breakpoints. You can set a breakpoint both in the key function editor here, and in the strategy here. Right click, breakpoint, and here in the key function editor, just click the gray bar, gray sidebar. So how works a breakpoint? When the program flow reaches a breakpoint, here, or if I set in this block, the program stops. So now you see that the program is running. As soon as it reaches this line, we will see the simulator change in pause state. Okay, let's try. So click ESC up. In fact, you can see that the simulator is in pause. The yellow line and the yellow arrow points what is the next line that will be executed. And now we can continue step by step using this button. Step into means execute line by line. So what do we expect from this code? Now, do we expect that the next line is this, or the other if, or whatever else? So since unit status is 0, this condition is true. Unit status is equal 1 is true. So we expect that the next line is this. Okay, so click step into. In fact, works. So the next line is this. You can see that the unit status is still 0, because this line has not yet been executed. But as soon as I click step, you can see that the unit status now is 1. Well, so far so good. The code so far works perfectly. Well, this line was the only line that we needed to execute when this condition is true. So exit from the group and continue with the next code. In this case, there is another test condition. So now, this condition is true or false? UnitStatus is 1 or not? UnitStatus is 1, so this condition, also this condition is true. Since it is true, it executes also this code that will write 0 in UnitStatus. And there is UnitStatus back to 0. Okay, I think that is clear what is the mistake. The mistake is that there is the mistake is not a mistake or an error or a limit of the system or the language. In this case was my mistake. I wrote a wrong code. So what happened is that when the first condition is true, it executes this line, but after that also this condition will become true, and so also this code is executed. So from 0 change to 1 and 1 change to 0. This is the problem. So how to solve this problem? Okay, let me remove the breakpoint. Okay, first of all, don't, for who knows any textual language, programming language, probably are thinking about the else statement. So if this condition is true, then write 1, else, so instead of this, probably you would try to use the else, do this. But else statement is not supported. As told you, the implementation of the C language here is very, very restricted. So we can't use the else. So we have to find a workaround. What are the workarounds? There are two workarounds. One is more, in my opinion, is more simple than the other. So in the exercise book, you can see both solutions. I will show here only one of those two. So the workaround that I will implement needs a new support variable that I will call new UnitStatus. It's enough to put it in RAM memory. Okay, I will remove all this code and write again. Control space, if open, control space, the user variable, enter, UnitStatus is equal 0. Okay, this line is exactly the same as before. Then what? Then the user variable new UnitStatus is 1. This is the difference. In the previous code, I check UnitStatus and I modified the same variable. So I override the same variable. While now I write the opposite value into another variable. So I won't modify the value of UnitStatus. After that, vice versa, if the user variable UnitStatus is equal 1, open, then the user variable new UnitStatus is 0, close. So the line 1 and 5 check the current status, and the line 3 and 7 write the opposite value in the other variable. I made a typical mistake, columns instead of semicolon. After that, we have to assign to the variable representing control space, the user variable, the variable representing the status, the other value. user variable new. So check current status, write the opposite value in other variable, and then assign the new value into unit status. This is one of the two solutions. Okay, I'll try again. Now unit status is 0. Now it becomes 1, 0, 1, 0, 1, 0. So now works better. Not perfect, but better. Why? Because if you, maybe you have already tried, but if you press and hold down the button, after 1 second starts the auto repeat. As you can see, the correspondent code is executed continuously, and so the unit status changes from 0 to 1, 1 to 0, 0 to 1, 1 to 0. Well, is this an issue or not? Depends, because if you use unit status to enable a device, for example a compressor, you will have the compressor that start, stop, and you will destroy the compressor. Okay, real application has a safety timing for the compressor, but anyway, it's better to fix this problem. Well, the only way to fix the problem is use another system variable. In a previous exercise, we used key pressed. Now we use key counter. Okay, in the user manual you will see all the details regarding key counter, but probably is easier if I show you here the simulation. Key counter works in this way. You can see that now key counter is a given value. As soon as you click a button, key counter becomes 1. So when you click any key, key counter becomes 1. But if you press and hold down the key, after 1 second, key counter takes the value 10, and after increases by 2 every 0.2 seconds. So in general, key counter represents the time the key is pressed, is maintained down. So try another 2 times. When you click, it's 1, but if you click and hold down, 10, 12, 14, 16, 18, and so on. But the question is how this variable can help us to fix the problem of auto repeat. It's simple, because key counter takes the value 1, not all the times the code is executed, but only when you click, let's say the first time you press, as soon as you press the key. So we can modify the code taking care also of key counter. So end control space, the sysbar list collector, it contains the list of all system variables. Okay, key counter, okay, this one is equal 1. So this condition is true. This is one premise. This condition is true only as when we press the key. When the auto repeat starts, key counter is 10, 12, 14, 16, and so on, and so this condition will be false. So this character stands for end. So in this language, only the end is supported. The or, the not, okay, and other operators are not available. Okay, do the same here. And control space system variable key counter is 1. We have to add also here the condition sysbar list key counter is 1, open. Here we could avoid to write open close, because in C language when you have only one statement the open close curly bracket are optional. Anyway, again start simulation. Now unit status is 0, 1, 0, 1, 0, so it works like before. But if I press, now I'm holding down the ESC up key, you can see that auto repeat is running because key counter is increasing, but the unit status is fixed to 1, the value 1. I release, press again, so from 1 change to 0. Auto repeat is running, but the unit status is fixed to 0. So this solution works. Well, and that's all for the step number 1. Step number 2, we can enable before to enable we can show the status of the unit here in the somewhere in the user interface. I think that it is enough to show it in the main mask. By the way, I remind you that in OneTool 2.7 we have added the Control Tab shortcut to move from the mask editor to the strategy editor. It's very, very convenient. Okay, Control Tab to go to the mask editor, click the mask, place another text. Okay, this is a unit is now place a field. The variable is unit status. Here is the format as usual is the correct one. Enter. Now I have a question, but what we will see here in this field? We will see 0, 1, off, on, no, yes, this n, whatever else. Okay, there are 2 ways to do this. The first is to, let's say, think as the operating system works. That is, it searches, first of all, at field level. It searches, okay, this is first level, field level, searches for the resource used on bool. Since it is empty, it searches at mask level. Mask level is empty, so it uses the global level. And here is the resource used on bool of on. For this reason, in that field, we will see of on. Another way to see, to have a preview of what you will see in runtime, is to use a new property of the field called simulation value. So when the property is empty, you will see in the field the letter or the letters representing the data type, B for Boolean, I for integer, A for analog. And while if you write a value, for example 1, you have a preview. So when in this field, when the value of the variable unit status is 1, you will see on. When the value is 0, it is off. So this is another way to have a preview. Okay, I won't test it now because it is so simple. So we can go on with the third and last part of the exercise. That is the enable of the devices. So in a previous exercise, we have enabled the cooling and heating according also to the enable of the corresponding device. Now we have one condition more. So since we have one condition more, we can just do what we have done before. So we could just add a new end here, something like this, with the variable UnitStatus. This is a good solution, but this is a good opportunity to use our first macro block. So far we used atom blocks from this library. Now we use a macro block. A macro block, I told this in the first exercise, is simply, let's say, a box containing other atoms or macro blocks. Exactly as a folder in the disk, it can contain files and folder that can contain files and folders and so on. So in general, macro blocks perform more, let's say, complex or complete function to manage not only generic function, to implement a generic function, but to manage specific function or devices. For example, we have a list of macro blocks for the alarms, high pressure, low pressure, and so on. Macro blocks for the conversion of the unit of measurement, bar to PSI, and vice versa. More complete blocks for the timing, scheduler, delay timers, okay, and so on. To manage the compressors, start-stop sequence of the compressor, protocols, and so on. So one of these block is the end3. So end3 is like the end, but with 3 gates. There is the end3 up to the end10. So I can delete this, move this over the pin, also here, and then connect. Okay, another way is replace the block with a new block. So right click, factoring, replace block, replace with the end3, here is. So when you replace a block with another, if in the new block there is a pin with the same name of the old one, the existing one, the connection is established like before. You can replace only with this block, this instant, or all the block in this page, or everywhere. And here is, I can put this here. Okay, so now we have 3 conditions that enable the cooling and other 3 that enable the heating. This is really all for this exercise. Quick test. Now the project is becoming more and more, let's say, difficult to test, because in the first exercise there was only 1 condition for the cooling and 1 for the heating. Now we have 3. So if we start the simulation, well, you can see that the temperature is very high, but the cooling is off. So now there are 3 conditions that enable the cooling. So the problem is one of these 3 conditions. In simulation, it is easy to find where is the problem, because if you show the pin values and you locate the block, okay, you can see that the cooling is 0, is off, because of this block. Because this block receives the values 110, while we probably expect to have 111. So the problem is in the third value, that is this. So the problem is in the unit status, as you can see here. So we have to switch on this. In fact, now you see that the cooling is switch on and switch off. After that, let's try also the heating. Here is the heating, unit off. By the way, you can see that we have the feedback in the mask. Off, unit off, and so the relay is forced off. And so this exercise works perfectly. Well, before to finish, I would like just to remind you that in the quick reference, as well as the manual and the exercise book, there is the list of the key points regarding the key function editor. Most of them, we have seen most of them. There are some other remarks. Particularly, you can see that here how to add remarks. There is a prefix // or /* // collector is optional, and you can use you can copy and paste the code between two different keys. Okay, that's all also for this exercise. Thank you for watching this tutorial.